Hello students, this is Mr. McAllen, and today we're going to be talking about ellipses. And ellipses are basically variations of circular equations. And the basic circular equation that we went over in class the other day was x squared plus y squared equals a radius squared. And that's where the circle is centered at 0, 0, and it has a radius of whatever the square root of what would be on the right side would be. We did some variations where we had x minus 3 squared plus y minus 2 quantity squared equals like 16, and that resulted in a circle that had a center point of 3 comma 2 and a radius of 4. So now we're moving on to elliptical equations, and in these equations the general form is x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, this may vary, but basically the major axis is going to be the larger number. So if your major, if A will always be the major axis. So whichever term, whether it be the first term or the second term, has the larger denominator, that will be the A value squared. So we're going to go through a couple examples, but the major axis is always related to the A value, which would be larger than the B value. So A is a major axis, B would be related to the minor axis, and we have a C value that has to do with an equation that relates them to both, but we're going to go into that as we do an example. So in our first example, we want you to look at an equation of an ellipse, and we'd like you to come up with what the center would be, the vertices, covertices, and foci. So, so here we go. The best way to explain this is to draw a picture. We write out the equation, x squared over 25 plus y squared over 4 equals 1. And our a squared value is equal to 25. That means our a value is equal to 5. Our b squared value is equal to 4, which means our b value is equal to 2. So what this means is our major axis is the x or horizontal axis, and our minor axis is the y-axis. Why is that? It's because the value of what's under the y is less than the value of what's under the x. It's that simple. When we draw a picture of this, a lot of things will become more clear. We need to know where the center of our ellipse is. And because our general equation for an ellipse is x minus h quantity squared plus y minus k quantity squared, this would be over b squared, this would be over a squared, because our h is equal to 0 and our k is equal to 0, we are centered at 0, 0. Because our major axis is underneath the major axis value, the larger denominator is underneath the x, we know that our ellipse basically has a shape like that. It should be more symmetric, but it basically has a shape like this, and now we need to fill in the values so we can draw the function. So let's draw our major vertices, or what they would call just our vertices. Our vertices are going to be at the points, because we're at 0, 0 as our center. Our major vertex over here is going to be at value a, 0, and our other major vertex is going to be over here at negative a, 0. So what we do is we figure that out from the 5. So this is basically 5, 0 and negative 5, 0. Our minor vertices, or as some people would say, our co-vertices, are going to be at up here above the center point. that would be 0 comma b, and this lower value would be 0 comma negative b. So when we draw that, when we look at it, it's basically going to be 0 comma 2 and 0 comma negative 2, and now we have enough information to draw our ellipse, which is a terrible picture. So let me try to do that again. So that would be what our ellipse would look like. The last thing we need to do is we need to find out where our foci are. The foci are these 2 points that are focal points of the ellipse. So the foci are basically at the coordinates, because this is an x-axis ellipse. The foci's coordinates are at c comma 0 and negative c comma 0, and there's a very easy equation that relates them. It's related, it kind of reminds you of Pythagorean theorem, but it's not. It's c squared is equal to a squared minus b squared, and this equation holds true no matter what type of ellipse you're working with. So because our our a value is 5, then you have 25 minus 4 for your b squared value, and our c value would just equal root 21. So the value of this focal point would be root 21 comma 0, and of this focal point would be negative root 21 comma 0. So we've gone over an awful lot as far as for setting up these ellipses, but this is just an ellipse that is centered at 0, 0. We come to our next example, and it says for the ellipse equation below, find the center, vertices, co-vertices, and foci for this equation. Now this equation is fully developed. It's an ellipse that's been moved basically 3 to the right and down 5. So we know where the center point is right away, just like we found the center point for circles. So the center of this ellipse is going to be at 3 comma negative 5. So I always like to draw a picture because I think a picture is worth 1,000 words. So it's much easier to see it if I draw it. So we're at 3, and then we go down 5. So we're at this point here, 3 comma negative 5. Now, we have to identify if we have an x-axis ellipse, which is a major axis, or a y-axis ellipse. And because the 25 is larger than the 4, I know my a squared value is, or my major axis, the a squared value is equal to 5 again, and the b squared value is equal to 4. So that would mean that my a value is 5 and my b value is 2. So from this center point, I can draw I guess you could call them the boundary points of my ellipse. I'm going to go basically to the right by 5. So I'm going to go out here to 8 comma negative 5. I'm going to go to the left. I've got to go 5 to the left. So that's going to be over here. So it's going to be at negative 2 comma negative 5. And I want to keep this in scale, so I'll probably move this point out a little bit more. 8 comma negative 5. Now I'm going to draw my minor axis values, which just means I'm going to go up 2 and down 2. So I'm going to be at 3 comma negative 7 for this point, and I'm going to be at 3 comma negative 3 for that point, because all I'm doing is going up and down a minor axis amount. So now I'm going to draw my ellipse, and the last thing I'm going to do is draw in my foci. Now remember, these are the co-vertices, the ones for the smaller axis. This and this is my major vertices, or they would just call them the vertices. So this again is a co-vertice. And this is just called a vertice because it's on the major axis. So anytime you name a vertice, we're basically talking about the vertice of the major axis for the ellipse. Anytime you have a co-vertice, that would be where the b value took you for the minor axis. The last thing we have to do for this is we have to name the foci. Now the foci only exist along the major axis. The foci would be about here and about here. And the equation for that again is c squared equals a squared minus b squared. From before, because we're using the same numbers, that's going to be root 21. So in this case, what we have to do is from the center point, we have to add or subtract root 21 from 3. So this first foci value will be 3 plus root 21, comma, -5. That would be its coordinate. And this foci, or focal point, would be 3 minus root 21, comma, -5. So those would be all the points and all the information that they wanted to know from us for this problem. The last problem we have is where we have a bit of a switch. I don't know if you noticed, but if you look at this equation, it's again an equation of ellipse. The center is going to be at 3, comma, -25. But in this case, because our a value is now underneath the y, the a is equal to 5, and the b is equal to 2. And because the a is underneath the y, it's now an ellipse with a major axis that runs vertical. So we're going to plot the center point. We're going to be at positive 3 in the x, down 5 in the y. So I'm going to be right here. But in this case, the ellipse is going to be an ellipse that runs vertically, like the little picture I have here. So because the a value is 5, I'm gonna mark the center point, just like you're gonna think about this when we do the worksheet in class. The center point is 3, comma, -5. So that's where we're at, 3, comma, -5. And I'm going to go up 5 in this case for my major axis value. So that'll be 3, comma, 0. That's the end of the ellipse. The ellipse will be coming down like that. And then I'm going to go down 5. So that'll be 3, comma, -10. Hopefully this is in scale. So that's what's going to go on up that way. I'm going to just draw this down a little bit more. I think it's got to go down about here. So it'll be 3, comma, -10. And now my minor axis is equal to 2. So this time I'm going to go 2 this way. So I'm going to go to 1, comma, -5. I'm going to go 2 to the right. I'm going to go to 1, comma, oops, sorry. I'm going to go to 5, comma, -5. And I'm going to draw my ellipse right through those points. Remember, they're the outside points. So it's kind of like when you draw a circle. I'm not a great ellipse drawer, but you can get the idea. Right? We have our center point, and now I just need to get the foci. Remember, the foci again is equal to c squared is equal to a squared minus b squared. So c is equal to square root of 21 again. I know I use the same numbers. I just want to stay consistent. But in this case, the foci values, the coordinates are going to be 3, comma, -5 plus root 21, and the other foci value will be 3, comma, -5 minus root 21, because it can go up and down from the y coordinate. I hope this video has helped you understand how to basically work with equations of ellipses, because these are the general types that we're going to work on the worksheet. We won't have to worry about any completing the square for our next day in class. We'll just have to be able to look at the equation and know how to figure out center, vertices, co-vertices, and foci. So hopefully this video has helped, and I look forward to hearing your comments.